In this lecture, we are going to discuss about electric field intensity on axial line due to an electric dipole. What is the heading? Electric field intensity on axial line due to an electric dipole. Due to an electric dipole. Very important. Very important. I mean, most important derivation is there. Okay. So let us consider an electric dipole. You know very well electric dipole. What is the electric dipole? Electric dipole is a pair of two equal and opposite point charges separated by a distance 2a. You know very well. Okay. So let us see. This is a one point charge, negative point charge. At shorter distance, there is another point charge. This is a positive q point charge, negative q point charge. Is it okay? Very good. Here is also, and both separated by a distance. Both separated by a distance 2a. You can consider 2l also, you can consider 2a also, no problem. Okay. Now you can take on center point. This is center point. So center point means here to here distance will be a, and here to here distance also will be a. Is it okay? Now you are going to be consider one another point on this axis here P. This is a P point. We need to find resultant electric field at P. Okay, at P. Due to this point charge, due to this point charge. If you are going to find electric field at P due to this charge at P point, then what distance you will consider? This distance. So before considering this distance, you need to consider distance here to here. You need to consider x distance. This center point you can put the point name O. O to P you can consider x. And this point you can say A, and this point you can say B. Is it okay? Till here any doubt? No doubt. So if suppose that you are going to find electric field at P due to this positive q charge, so you will take this distance. For finding electric field, you need one charge and distance. So charge is there, distance you will take this one. So if you are going to find this distance, so see, here to here distance is x. If you are going to find here to here distance, so you know very well here to here distance is a. So distance will be here to here x minus a. What distance you will consider here? X minus a distance. Is it okay or not? X minus a. Sure. If you are going to find electric field here at point P, so you know very well electric field is a vector quantity. So direction will be this side, away from the positive. Is it okay? Similarly, if you are going to find electric field at P due to this negative q charge, so due to this negative q charge you are going to find, so distance you will take here to here, it means A to P distance you will consider. So here to here is a x and this one is a. So total distance will be, here to here distance will be x plus a. Is it okay or not? So distance is this, charge is this. So electric field we need to find at P. So direction will be which side? So this side. It means E2. This side. This is a E2. Towards the negative charge. Is it okay? So now we are going to write the formula. So see, electric field at P. at P due to positive Q charge. Due to positive Q charge. So electric field you can write. So you can write here E1 is equal to, okay, 1 upon 4 pi epsilon naught into charge positive Q. So Q divided by distance square x minus a square. Equation first you can say. What is the direction? Away from the positive charge. Away from positive Q. Away from positive Q. Is it okay or not? Similarly, electric field at P due to negative Q charge. Due to negative Q charge. Is it okay? Due to negative Q charge. So you can write here E2 is equal to 1 upon 4 pi epsilon naught charge negative. So negative Q divided by distance x plus a square, direction towards the negative charge. So you can write here towards negative Q charge. Okay, towards negative Q charge. Is it okay? Clear in doubt? Now resultant electric field. Now resultant electric field at P. Resultant electric field at P. So you know very well. So you can write here E is equal to E1 plus E2. Is it okay or not? E is equal to E1 plus E2. If you are getting confused, here I wrote vector. So you can write vector also, no problem. Okay. Like this also you can write. But if you are writing vector means you are going to place the direction also. So direction of E2 is a negative. Here you can see here negative. So now you can place here. So you are going to write. You can write also like this. So E will be is equal to E1 1 upon 4 pi epsilon naught into Q upon x minus a square. Very good. Minus this one E2 1 upon 4 pi epsilon naught into Q upon x plus a square. If suppose that you are writing here negative Q charge, so you will write here E1 plus E2. If you are taking here positive Q charge, so resultant you will write here E1 minus E2. Do remember this thing. Okay. So now you can solve this one. If you are going to be solved, so it will be equal to E is equal to, you can take common 1 upon 4 pi epsilon naught and Q is a common. So Q upon 4 pi epsilon naught is a common. So you can write 1 upon x minus a whole square minus 1 upon x plus a whole square. So now you can solve Q upon 4 pi epsilon naught. You can solve this. So it will be x plus a whole square cross multiplication, okay, minus x minus a whole square divided by a minus b, a plus b, a square minus b square whole square. Is it okay? Now you can open. So it will be is equal to Q upon 4 pi epsilon naught. So you can open this one. So a square plus b square plus 2ab. Very good. Similarly here a square plus b square minus 2ab. So minus is there. So it will be minus a square. Okay, this minus will come here now. Okay, so minus x square. So a square plus b square. So plus b square means this is a. So a square. So plus minus minus. Minus a square minus 2ab. It means minus 2ax. Minus 2ax. So minus minus plus 2ax. So minus 2xa divided by x square minus a square whole square. Is it okay or not? After this, you can see here. Okay. So now E is equal to Q upon 4 pi epsilon naught, this one, minus x square plus x square, a square, this one. So it will be equal to 4xa divided by here x square minus a square whole square. Is it okay? So now you know very well, if suppose that you are going to write this one condition, this one is 4xa, so you can just write like this. How I am writing? E is equal to 1 upon 4 pi epsilon naught into, okay, so q into 2a into 2x. Is it okay? 2 2 ja 4. So why I am writing q into 2a, I will tell you later. So x square minus a square whole square. Is it okay? So we know very well, last time we discussed electric dipole. So we know very well, because q into 2a is equal to electric dipole p. Is it okay or not? Yes, very good. So this is electric dipole. You can write here electric dipole. Okay, no problem. You can write here. If you want to write, you can write electric dipole. No problem. Electric dipole. After this, you can write E is equal to, what you can write, 1 upon 4 pi epsilon naught into, so you can write 2p x divided by x square minus a square whole square. Is it okay? So now see, x square minus a square, as compared to x, a is very small. As compared to x, a is very small. If a is a very small means, so now what you can do, because x is much greater than a, it means a is very small. So now you can write here E is equal to 1 upon 4 pi epsilon naught into 2p x upon x power 4. You can remove this one, neglect. Okay, so 1 power cancel, so power will be 3 here. So E will be is equal to 1 upon 4 pi epsilon naught into 2p upon x cube. 2p upon x cube. This is a required formula, Newton per Coulomb. Is it okay or not? You can consider here r distance. You can consider here r also, no problem. X you can consider, r you can consider, as you can consider, you are free. Is it okay or not? So now you can understand how we can derive this relation, electric field intensity on axial line due to an electric dipole. So this is an electric dipole. After that we consider one point P on this axial line, and after that what we did, we got electric field at P due to this charge, and after that electric field at P due to this charge. After that we equated, okay, we got resultant electric field according to that sign convention we applied here. After that we resolved it, so finally we got. Is it okay or not? So this is a final answer, final derivation of this problem. Either we can say heading. Is it okay or not? Thank you so much. You please subscribe this channel and you please support. If you have any doubt, any query, any problem, you please give the comment also. You can just join the WhatsApp group also. Thank you so much. We will see you in the next lecture.